Let's give Dr. Bostwick a warm welcome.
Thank you. Thank you, Jim. Thank you for all coming out. And tonight I'm going to talk about Hohokam Irrigation. As a Phoenix City archaeologist, I was involved in a lot of excavations that discovered canals. And Phoenix, of course, is named, got its name because of the bird that rises from the ashes of its own self. And the individual that named Phoenix back in the 1800s realized that it was built on an ancient civilization, and that's the Hohokam culture. And a lot of that are the many canals that are spread throughout the Salt River Valley and other areas of southern Arizona. So I'm going to talk about those canals today because they really are one of the great wonders of Arizona. In fact, I found when I was working with the city that people, especially engineers, would come from all over the world to learn more about the Hohokam canals. And the reason being is because their engineering was so sophisticated for a pre-industrial society that the canal system is considered one of the most expansive prehistoric canal systems ever constructed in the New World. So what I want to do today is talk about some of that research, a history of canals, and what we've learned about how the canals were constructed, how they were used, and how the Hohokam relied on the canals, and ultimately how the canals contributed to the collapse of the Hohokam civilization. So let's get started. The Hohokam Canal system in the Phoenix region, Salt River Valley, was studied in the 1920s by a guy by the name of Omar Turney. And even though he wasn't the first person to seriously look at the canal systems, he was the one that advanced the study the most. He was actually an engineer himself and had worked on the Roosevelt Dam. In fact, a lot of people are not aware that Omar Turney actually named Roosevelt Dam after the president. And he did many other things. He surveyed Phoenix. He actually came up to Verde Valley and wrote a report about all the water theft that was going on illegally in the Verde Valley at the turn of the century. And so he had a long history of looking at the movement of water and the design of waterways in Arizona, and we can thank him for really promoting the study and also the preservation of canals, because he is buried at Pueblo Grande. A lot of people are not aware of that, but his ashes are in the Parker Four Waters of Pueblo Grande, which was his dying request, because he was largely responsible for the purchase of the massive canals, which I'll show you and talk about, at Pueblo Grande, and the city acquiring those canals and preserving them and becoming part of the Pueblo Grande National Historic Landmark. So the man is really a giant when it comes to the study and preservation of Hohokam canals. This is his map that he prepared in 1929. This map is still in print and is distributed around the world. And even though we found more canals and we've corrected some of his information, it is the standard canal map that appears in every report, even today, that archaeologists write about Hohokam Canal. So Omar Turney is really a giant in the world of Hohokam engineering and canal construction. And as you can see from this map, he covered, in this particular study, he wrote a book, by the way, in 1929, right before he died. And it's a thick tome, and it's got all kinds of interesting information, and it's very valuable because he field walked all of the canals through his career. And he recorded archaeological sites, some of which no longer exist, or portions of them have been destroyed. And so the archaeological data that's present in his 1929 book is a classic work that's still very valuable. I'll point out that let's see if this is working, yeah. We start here with Mesa, and we end up all the way down here in the western part of Phoenix area. And all of these names here are all Hohokam villages that sprang up because of the canal system. And I often get asked, how many Hohokam lived in the Phoenix area during this canal system? And I can tell you the two main figures that have been quoted are 24,000 to 50,000 people because of this canal system. And it never would have happened without the canal system. In fact, Phoenix would not exist today as it does if not for this canal system, because the development of the city of Phoenix in 1860s was because somebody saw remnants of the Hohokam canals and said, hey, you can water this desert and you can grow farmland and people can move here. And that was an accurate prophecy. And in fact, we know that about 12 to 14 of the historic canals that were built in the Phoenix region, at least 65 miles of canals, were either exactly in a Hohokam canal or parallel to a known Hohokam canal. And the reason that is because the Hohokam had no mechanical devices, they had no pumps, they had no animals for labor, they had dogs, but there's only so much a dog can do for you, certainly when it comes to building a canal. And so it's all hand done and it's all gravity fed. So this entire canal system is gravity fed. And that means every canal has to be at grade from the entire length of the canal, which could be anywhere from 7 to 20 miles in length, which means you have to have survey instruments. It's a remarkable achievement in the history of humankind in the New World, the Hohokam Canal System. Turney named the different systems that he recorded, and we still use those. The two main systems that you see here are System 1, which starts in Mesa and then goes down to Chandler, and then System 2, which starts in the Tempe-Phoenix boundary here and then feeds most of the southern half of Phoenix. And that's where Pueblo Grande is, and Pueblo Grande is the largest platform mound ever constructed in the history of the Hohokam. And the reason being is because it is at the head gate of Canal System 2. So they controlled the water for a whole series of other villages down Canal, and was the central point for the Hohokam occupation of the north side of the river. Except for over here, which is Scottsdale, and you can see this dinky little thing, and this was added much later, and I'll talk about that as we move through this. Now, the Pueblo Grande sponsored the Army Air Corps of Engineers to come out and take photographs of the Hohokam canal systems in the 1930s, and they took these aerial photographs. And here is the Pueblo Grande platform mound largely before it was excavated. And here's the remnants of the two Hohokam canals that are very famous, the North Canal and the South Canal, that are part of the Parker Four Waters. And here's the historic Grand Canal. And by the way, this historic Grand Canal parallels the Hohokam Canal, goes almost to Glendale, and is 20 miles long. So one of the major historic canals still in use today is modeled after a Hohokam Canal. So, Salt River. What do we know about the Salt River? Well, we know that it used to be a really wild river before they put all the dams on it. In fact, it was so wild they had to put dams on it because it was flooding out people's homes and buildings and fields on a regular basis, and they realized if we don't dam the Salt River, we're never going to be able to develop this part of Arizona. And so, fortunately, there was some really good engineers who studied the flow of water in the Salt River before the dams were built. The first major dam, of course, is Roosevelt Dam, completed in 1911. And that was the beginning of taking control of the Salt River. So that dry channel that you see today, that when my relatives from Germany come and say, "You call this a river?" was once a mighty river, believe it or not. And you can see here that the flow of the river before it was dammed is seasonal. And so you have a steady flow, and then there's this big peak of acre feet, up to 300 acre feet of water times 1,000 that occurred between January and April. So when you're designing a system, you have to know that this is when the major flows of water are going to go through your canals, and you have to design it accordingly. And you can see here that there is water that's in it year-round, though, or was year-round. So you're always going to have water. So what does that tell you? It tells you that you want to have your canals in good shape when the peak flow comes, and when you have the low flow, that's when you're getting in the canals and you're maintaining them. And anyone that knows anything about canals will tell you that the maintenance of the canals is as difficult as the construction of the canal. Because once you build one, you're not done with it. You're going to be maintaining that canal for as long as you use it. Because the process of water is that it carries sediment. And that sediment will either drop as soon as it gets into your canal, or it'll go down and drop somewhere else. And in fact, what we found that the reason that the salt river soils are so productive is because the sediment in the water provides the nutrients every year after the floods, so that the Hohokam never had to fertilize their fields, because the flood water brought the sediment and dropped it. But the challenge is, how do you get the sediment to not drop in your canals and fill them up and clog them up, but instead drop on your fields? That takes engineering. So there's so much engineering that went into this canal system, and I'm going to talk about that engineering throughout the rest of the night, so you can get an idea of what a really amazing knowledge it took for these people to create this system that was sustainable for several centuries. In fact, the Hohokam occupied the Salt River Valley for 1,000 years. And most of that was because of the canals that they engineered. Now, when you talk about irrigation in the desert, one of the things that you always have to be aware is the issue of sustainability. And sustainability is, of course, to be able to maintain soil quality, to have adequate water, and to manage your water efficiently. And one of the great things about southern Arizona is that if you can do those, you can double crop. And that means you can do 2 harvests a year, which doubles the amount of food that you get. And when you double the amount of food that you get, you can create surplus. And with surplus, you can trade. And with trade and surplus, that's how great civilizations are built. So what is it that were primarily their surplus? Well, of course, it was corn and cotton. And we know that the Hohokam were, at any one time when the canals were going full blast, grew up to 100,000 acres of corn. 100,000 acres of corn by a pre-industrial society. It's really phenomenal amount of corn. And they grew large quantities of cotton. And in fact, the Hohokam were the cotton kings of the Southwest for a long time. Most of the Southwest was getting its cotton up until about AD 1000 or 1100 from the Hohokam, because cotton requires warm weather, long growing seasons, and lots of water. And really, the Phoenix region is ideal for all 3 of those. And it only was after they had hybridized the cotton seeds where they could grow at higher elevations and colder climates that the rest of the Southwest could start growing their cotton. So the Hohokam monopolized the cotton industry for at least 400 or 500 years in the Southwest. And a little bit of trivia, you hear the word Pima cotton, and you can buy Pima cotton t-shirts that are really good quality and other kinds of cotton. I'm sorry to let you down, it's not Pima cotton, it's actually Egyptian cotton. When the cotton industry sprang up in the 1910s and 1920s in Arizona. They looked around the world and said, who has the best cotton? And that was in Egypt, and it was a similar climate, and so they brought seeds over here, and so the whole cotton industry that we're familiar with today is actually transplanted Egyptian cotton. The Pima lost their ability to grow the Hohokam cotton, and we're not even sure exactly specifically what kind of cotton variety they were growing, although we do have some historic Pima cotton before the Egyptian cotton was introduced. That does give us some ideas. And in fact, today, I'm involved in a major worldwide cotton study for looking at the evolution of cotton in the Southwest using cotton seeds from the dike collection. Because the dike collection has as many as 1,000 cotton seeds. It's one of the largest cotton seed collections from one archaeological site anywhere in the Southwest. And so what we're trying to do is look at the evolution. Right now, there's only 2 known historic cotton progenitors, and that is the Hopi and the Pima cotton. So we're doing DNA testing on the dike rock shelter, or cliff dwelling, I should say, cotton, and comparing it to those 2 historic, and then trying to see what we can tell about its evolution. Now, the one thing about Hohokam irrigation communities is they were limited, because even though the Salt River was a mighty river, and you had the Gila River, which wasn't quite as mighty, and then you had Green Creek, which is much smaller, but also had annual flows. We know that there were 16 irrigation communities, and we call them irrigation communities, and that's because it's all the canals that can come from one head gate. The head gate is the key part of creating a canal system, is because you got to get the canal out of the water out of the river into the canals, and there's only so many locations you can do that. And the Hohokam actually maximized every single possible location to bring water off of those 3 rivers, or 2 rivers and a creek. And 10 were in the Salt River, 5 on the Gila River, and then 1 on Queen Creek. Typically, the canal intakes, as we call them, are located where there's bedrock masses. So why would you want to start a canal where there's a bedrock mass in the desert? It forces the water up higher to the surface, and so you can bring it out for the river, because the water's going to be high up, higher than other places of the river. And then also where the river channel is narrow, and again, you're forcing the water inward, and then where there's a confluence of major tributaries. So if you don't have those 3 conditions, the odds are you're not going to be able to create a canal head gate and then multiple canals off of that head gate. And so we know, we have evidence, a lot of canals have been excavated, and we know that these irrigation communities were all that was possible. They had absolutely maximized the amount of water that could be taken off of these waterways and then use them to their maximum efficiency. And that's a relative term, because even the Hohokam were constantly adjusting the engineering to deal with water velocity. Because one of the things about controlling water is how fast the water is. And why do you think how fast the water is moving in your canals makes a difference? Well, it goes back to sedimentation. Because how you control where your sediment load drops is how fast your water is going. Because slow water drops it, and fast water takes it. And so you have to reach a balance. And in fact, the Hohokam had figured out how to vary the speed of the water where it was in the system. Because you also have to slow it down if you want to take it out of a canal. So it was a master understanding of the principles of water velocity and how to control the velocity of the water, as well as a number of other important characteristics. There's yours truly standing at the famous South Canal, and even though the canal that's been preserved in the Park of Four Waters at Pueblo Grande, it actually headed, we now think, probably at Tempe Butte. And why at Tempe Butte? Because you got a massive bedrock, and that's where it's forcing the river up, and it's an ideal location to put head gates to get the canal, get the water to go into the canals. And these are very large canals. to give you an example, here's an aerial photograph by the Adriel Heisley that shows you the North Canal and the South Canal and Sky Harbor. Why is Sky Harbor important? Because what I found out, working for the city, is that there are dozens of canals under the runways. In fact, you may not realize it, but every time you land at Sky Harbor, you're actually landing on top of 2 major Hohokam villages that were there because of all the canals that went through there. And a lot of them have been excavated. We've learned a lot about the canals there, and I'll be talking about that later on. But as you can see, here's two canals here that are in the Parker Four Waters, the North Canal and the South Canal, and the Hohokam Expressway, which is a very important feature when it comes to canals. But the North Canal, for example, is 30 feet wide and 10 feet deep. So the Hohokam built really big canals when they were close to the river. What they understood is if you want to manipulate the velocity of water, the size of your canal and the shape of your canal influences its velocity. So they varied the size and the shape of the canal so they could control the velocity of the water that's going in it. They never were able to actually control the velocity of the Salt River. It was too wild. They never were able to build a dam on the Salt River. But they would build weirs, which would be short, little stubby dams sticking out at a 45-degree angle to push the water up there to go into your canal. But that's the only way they could manipulate water in the Salt River itself. So as long as you can get it into the canal, the key is in manipulating the velocity within the canal itself. Here's a picture of the berms of the South Canal. All that was excavated, and what you don't see is that's only the very top of the canal that's filled in. These are massive canals dug by hand. And all that came out of the canal. And also, you have to be careful when you excavate these berms because you have reverse archaeology. Because the berm is coming out of the bottom of the canal, so you keep adding and adding and adding. So the older part of the berm is actually in the lower part, and the latest is at the top, which is contrary to the normal principle of archaeology, which is the oldest at the bottom. And so you have to understand the principles of how they maintain the canals, how they cleaned them out, and how they added to already existing construction material from the canals. Now, those berms are handy for what, would you think? For floods. When the water raises up by the river and you have no control, the berms are going to be handy to keep it in the canal. Because there's the 2 worst things that can happen in a canal system are a breach, which is the water is not in your canal anymore, it's all over everywhere else. And the second thing, of course, is that it goes too slow. Because that means all the sediment drops and now your canal is clogged up and there's no water going to go down. And they had to deal with those things on a regular basis. So, at Pueblo Grande, Parker Four Waters, you have the 2 canals that got excavated early on in the history of Hohokam archaeology in the late 50s. And then you had the Hohokam Expressway that went in the 70s. And when they put that Hohokam Expressway in, which you drive over if you're going to the airport off of I-10, they found 18 Hohokam canals. All the way down next to the river and going all the way down up to Washington Street here. And this is just the right-of-way of the Hohokam Expressway. And as you can see, the 2 large canals are extending into the Hohokam Expressway. So this study done in the 1970s was really an important advancement in our understanding of the canals because it was a complete exposure of a major area for canals. But that's not the only place there are canals. This is a completely intact canal on the Salt River, Gila River Indian community. And Terry Leonard used to be their cultural officer out there, and he and I went out there a long time ago. It's Red Mountain there, and you can see where there's no development, this is what the canals looked like when the first settlers came. You could see them on the surface, and you knew something was unusual in that you have canals in the middle of the desert and there had to have been ancient people that built these canals. And so there are still a few places, Salt River is one of them, where you can find these completely unaltered canals. In this case, you can see there's a bend in it, and you can see all the river cobbles that have been dug out, because this is near the river to create the canal. And not only that, but out there you can actually see the fields that were being watered by the canals. And these are field boundaries, and we know that the Hohokam apparently created boundaries so that a family would know how many plots they have, and not only that, but when you're pouring the water on your fields, you know that if you're planting within these grids, that the water is going to stay inside your grid and soak into the soil and provide the nutrients and the water for your plants, your crops. So this is very rare, but here's a good example on the Salt River where you can still see the fields. And I'll talk about some more fields that were discovered in excavations not long ago. All right, so here's the schematic of how we think an irrigation system worked. And there's a lot of variations, but it's a good general diagram that shows you, here's the weir I was talking about. So the Salt River is on its way to the Colorado River. Actually, it's on its way to the Gila River, and then the Gila River goes to the Colorado River, and then it goes into the ocean in Mexico. Of course, you all know the Colorado River never reaches Mexico because we take all the water now, but once it did go that far. And so you have a main canal that comes off. That is to take the water out of the river and get it away from the river. That's its sole purpose. And then once you've done that, then you have canals that branch off of it, and you have what are called distribution canals. And then the distribution canals have what are called lateral canals. So it's a three-tier canal system: main, distribution, and lateral. And there's combinations of those, but generally that's a good principle to think of it that way, where you need three different sizes and locations of canals to get it to the fields, and you can see the laterals are watering all your fields here. Or in this case, you have a distribution canal that's going to water your fields, and there's less distribution canals. But and in here you actually have a canal that has an outlet, and you're watering fields, and it's not going down to the lower tier of your system. But there's something important to show you here. When you're taking water out, you have to slow it down, remember? Mm-hmm. And so how do you do that? Well, you can do it with what we call riprap. Some of you know what riprap is. It's basically a bunch of stones, and often broken ground stone. And they do a paving, and in fact, a lot of times it's also broken vessels. Combination of cobbles, broken ground stone, and broken vessels to create a paving. This slows the water down, and then you have gates here to control how much water and when the water is going into the second tier system. Because it might be that it's low flow in the river, and you don't want to have what is coming in here to go down here, because you got to maintain these canals. So you have to sometimes actually be able to stop it, or what are called head gates sometimes are slowing it down. And I'll show you how that happens with the way you design a head gate. And then another thing, as you can see, is a junction pool. It's the same principle, but in this case, you got to split your water here, and so you got to slow it down so you don't have a blowout in where you're splitting into two separate canals. And we look at the Pima, and the way they made their weirs was of mesquite poles that are driven into the river with branches arranged around poles and rock piled against the willow branches. So very primitive technology, but it works for a weir, slows the water down, raises it to get into your canal system and start on its way. And keep in mind that a simple weir like this could be taking water up to 20 miles away from where it originates, at grade all the way. What do I mean at grade? Well, there's some people in here who know what I mean. I'll talk about it later, because it's really important in the way you engineer your canals. Here's an illustration. I worked with a National Geographic artist, and we did a whole bunch of illustrations. And he's done a really good job. He's not with us anymore. Michael left us. But here's the main canal, and then here's the distribution canal, and then here's the lateral canal, and here's all the fields that are growing. And of course, I already talked about corn and cotton, but they grew a lot of squash, because squash is an unbelievable productive plant in Phoenix. In fact, any of you that have grown gardens know that squash will actually take over everything else. It grows so well. And of course, you can do a lot with squash as far as a food product. And there was, I imagine, in fact, you know, Phoenix is not the original name of that town. When it was Pumpkinville. And that's because with the first canals, the pumpkins took over everything. The squash took over everything. And so they called it Pumpkinville. And then, of course, when people started, you know, setting up government, they said that name is not, you know, sophisticated enough. And that's why an Englishman, Darrell Dupa, who was very educated in the classics, he says we need to call it Phoenix, you know, the bird that rises out of its own ashes, which is actually a very, very appropriate name. You also see here with the gate system, and they're opening this gate up, and you can see the water swirling through here. This is an issue because now this water is very destructive, so you've got to be able to deal with that turbulence there. And I'll talk about that. And we put a dog in there because, you know, you got to have a dog in the water. They love water. Okay, so how are they engineered? Well, they're gravity fed, as I said, and the gradient has to be surveyed. And that means you have to have survey instruments. We've never found a survey instrument in a Hohokam Canal, but we think we know what they used because there are other parts of the country where they're still using primitive survey instruments like Egypt and some other places. And so we got a pretty good idea what they're probably using. And in fact, here's one, an illustration. Take some saguaro ribs, you make an X, you put a cross, and you can actually do the length measurements and do a little bit of meth, and then you've got a really good surveying equipment. And then you just need a stadium rod. Again, you can use the saguaro rib, and then you put a sighting disc on it, and then you can sight, you know, this would be, and then you have a plumb bob here, so you know when you've got exactly 90 degrees. And so when you tilt it one way or the other, you know that that's going to be at an angle. And if that's the angle, that's the gradient that you need, you then can tell your surveyor or your rod holder as you go down, okay, you know, this is the angle we need to keep. That's the angle the bottom of the canal has to be constructed for the 7 to 20 miles long. And so it's not that complicated, surprisingly, with some simple instruments. So I often get asked, what's the ideal gradient? Okay, here it is. It's 3 meters per 1 kilometer, or that's about 3.3 feet per 1.6 miles. That means for every 1.6 miles of your canal, the slope on the bottom of your canal has to be 3.3 foot down, because remember it's gravity fed. So even though it's simple surveying instruments, you have to be good with them. Because the problem is if you don't keep your gradient, you're going to get a blowout or you're going to get your sediment drop because you're not going to get the velocity of water that you need to maintain. And believe it or not, the canals were built with these tools. A digging stick, a stone hoe, possibly what we call a donut stone that was used as weight, and a basket. I should say a lot of baskets. And that's it. You're digging by hand, you're putting it in the baskets, you take it out of the canal, you create your berm, and there you go. That's all the construction it takes. Of course, that's 100 people that are doing it at once, which means you have to organize those people. So you have to have some kind of form of government that's going to be able to organize 100 people working on a canal, and then to keep them working on it. And if it's a big canal, it might take them a year to work on it. So how do you get people to keep interest in building a canal for a year at hard labor? That's a good question. And archaeologists argue over how they did that. But one of our theories is that if you told them they got to share water, that was the incentive, knowing that all that labor you put in, you were going to get some of the water that's going in that canal to your field. And in fact, we now believe that there may not have been a central organization in the true sense where there was one family or a chief that was in charge of the canal systems. It was probably a farmers-run cooperative system, which you still see in Mexico today, where there might have been, the leader of the platform mound village that's at the head gate, makes decisions or likely resolves conflicts, because you always get conflicts with water. We know that it's still going on today. And so probably the central organization, their main job is to resolve the conflicts over the use of water, because you're not going to get the same amount of water every year, because the water flow and the salt every year is different. Some years are going to be low flow, and there's going to be some villages that don't get enough water, and who's going to make them happy? Well, you need a centralized authority that can do that. But as far as the construction and the maintenance, it was probably at a lower level, where it was villages and farmers that are actually making decisions and making sure the canals continue to operate efficiently. Now, here's a map that I prepared that shows you all the Hohokam villages that are in Canal System 2. And you can see that one system with just a head gate of 4 main canals, which I showed you in a previous map that are going through Pueblo Grande, are feeding all these villages. So that means Pueblo Grande is going to make sure all those villages are happy. And how do you do that? You just say, you're not going to cooperate, we cut your water off. People, all of a sudden, they start listening to what you have to say when they know that the head gate is in their village and they just close that canal and now you're not getting any water. So that's where the central authority would be in the head gate, and that's why Pueblo Grande is such an important site. And in fact, we think the 2 most important sites in the Salt River Valley were Pueblo Grande, which is at the head gate of Canal System 2, and Mesa Grande, which is at the head gate of Canal System 1. And what's interesting is that Pueblo Grande is on the north side of the river, so they control the north side of the river. Mesa Grande is on the south side, so they controlled most of the south side. But you still got to make all these people happy. And in fact, it's been argued by a colleague of mine that you have this massive Las Colinas that's got perhaps 10 platform mounds. Pueblo Grande has 1, maybe 1 platform mound and 1 tower, which is essentially a platform mound that's now evolved into a large structure like Casa Grande. So there might be more than 1 Casa Grande. We think there might be 3 Casa Grandes equivalents, and 1 was at Pueblo Grande. But even still, you can see size-wise, it does not match with Las Colinas. And it's been argued why Las Colinas is so big is this is the end of the system, and to ensure that they got water in low water years, they made sure there was a lot of people living there. And so if water was low that year, and Pueblo Grande says, well, we don't have enough to go around, all of a sudden, there's a delegation from Las Colinas, and they're at Pueblo Grande's doorstep, and they said, you better make sure we get water. And in fact, interestingly enough, at Las Colinas, there is an enclave of Patayan people, which is another culture from the Colorado River region in the Colorado Desert, and they're living at Las Colinas. And we know that because they have the ceramics that are very different than the Hohokam. And these Patayan people, probably human speakers of today, were probably there because they were migrant workers. And so we now think that the Hohokam may actually have had migrant workers to help, because your fields and your water is a seasonal, has seasonal intensity blips. So there's times of the year when you need a lot of workers and times when you don't need a lot. And you might have to use migrants to help you with those peak periods. And so what I like to point out is that the notion of using migrant workers in agriculture in Arizona, it looks like it goes back 1,000 years. It's an interesting concept. And you can see there's another system on the south side. It's a little smaller, the villages are smaller, and this is Canal 7. So this is system number 7 here, and different than system number 2, and they would have different challenges here. And when looking at the ceramics, we find that the communities that are on different sides of the river were probably independent of each other. Okay, so how did they organize themselves? Well, I told you that to have these irrigation canal systems, you had to have engineering, you had to have construction, you had to maintain it, and then you had to allocate and distribute the water, and then you had to have decision-making and conflict resolution. So to have a social political organization, you need those components, and we have all those components. And one of the leading scholars in looking at how the Hohokam organized the irrigation system is Jerry Howard. And Dr. Howard is a good friend of mine, and unfortunately he had a stroke recently, and he's retired from archaeology. So, but he's done a lot of really great work, and his dissertation was on Hohokam irrigation, so we have all that body of work that he did, and it's been very informative. This is a picture I took of him. This is a canal, again, on the Salt River Pima community, and you can see again the size of the berms here. And by the way, you drive by this. Every time you go to Fountain Hills, you're driving right by this canal system. It's right on the side of the highway. And thank God it's still there. I go and visit it occasionally, and of course, the Pima are very protective of their resources, and so they would never develop where a canal system like this is, because it's really a magnificent example of a Hohokam system. Okay, one of the things that Jerry Howard did was he said, you need to be careful looking at the whole system. I once calculated that how many miles of canals did the Hohokam build in the Salt River Valley? Does anybody have a guess? Total?
800.
Close, 1,000. 1,000 miles of canals. That's your main, distribution, and lateral. But those were never all in use at once. Keep in mind, the Hohokam Canal system was engineered in a large scale beginning about 8600. We have canals that predate that. There are canals that may date as early as 100 or so. But the big systems, like the ones I'm talking about, from 8600 until the collapse of the Hohokam in 1400. So you have, that period of time to construct canals, and what Jerry showed is that they weren't always in operation at one time, and in fact there's a growth sequence that we've been able to reconstruct. And so the earliest canals, as you could suspect, are going to be along the river, because then you have to do the least amount of digging. And humans are humans. They're going to do the least amount of digging they can get away with. But what they found was the problem with canal systems along the river, can you imagine what that is? That's where your houses are too. What's happening to your houses? They're getting flooded constantly. And they realized that's no good. So they actually re-engineered the canals to move them further up on the terrace. Now, the Phoenix area, you may not realize this, but it's actually sloped to the west. And that's why all the canals go in that direction, because that's the gravity fed. But it's also terraced. And there are two terrace systems on the north side and one on the south side, butting up against South Mounds. And so you got to get canals up on the terrace, and then you can run them along the terrace. So you have to design them that they may go a long ways. Like that's why when I showed you that canal at Pueblo Grande headed all the way down in Tempe, it's because they had to go that far down to be able to get it up on the terrace. And then once it's on the terrace, then they can put it where they want, because as long as they follow the contours of the land. Because you have to follow that means they have to survey the entire landscape, not just your canals, because they have to know what part of the landscape is going to allow you to do the gravity-fed system without any severe gradients. So he showed that through time they were moving further and further north, away from the river, because of the flooding problem, and also perhaps because of exhausting the soil. Even though I mentioned that you get all the sediment there, you still have to deal with the salinization that occurs. I mean, after all, it's a salt river. Why is it the salt river? Because it has high alkali content. It's a big debate in Hohokam archaeology as to effective soil salinization. There's no consensus on it, but I can tell you Jerry has written some really good literature that shows that he does not believe that soil salinization was the leading problem for the Hohokam. And there's a lot of good reasons. One of them is that when the historic farmers built their canals, beginning in the 1860s and really going to town by the 1880s, they encountered soil salinization immediately. And they found ways to resolve it. In the Hohokam, if you've got, 800 years of irrigation, you figure out what to do about soil salinization. One is you can let fields go fallow. And another is if you flood the whole field, you're flushing the soil, that salt out. I follow Jerry's position that soil salinization was not what caused the demise of the Hohokam, because it would have been a problem early, and then how do you last 800 years if you haven't figured out how to deal with that? But there are some Hohokam archaeologists that will still tell you that that was a leading contributor to their collapse. And of course, I just mentioned that, minimizing. And so down here is the 3 levels of organization. You have farmer cooperatives, which is multiple extended families. You have the village territorial groups, that would be like here. And then you have the headgate settlement leaders, which would be right here. So it's sort of a 3-tier social political organization that allowed the movement of people across the landscape, construction and maintenance of the canals, and the growing of the crops from those canals. And here's just some more detailed maps to show you. Here you have the Pioneer period, starting in 500 to 700. That's when they're first experimenting with these massive systems. And this is Pueblo Grande here. You can see it's not too huge. But by the colonial period, by 700 AD, it's starting to really boom. And what that means is they figured out the topography, they figured out the engineering, and pretty much from AD 700, there's not a lot of improvements that were being made. Oh boy, I better move along. Here we have Sky Harbor, and this is Dr. Kathy Henderson. She's done a lot of work on canals too, and what she's found in Sky Harbor is that when you have a long canal, you have to have a place that you can go and hang out while you're caring for the canal. That's not your home. And so that's what the field houses are for. And in fact, when they were working on the airport, they found they were paired. So you have one small pit house where you're hanging out for just part of the year, and another one where all your garden tools are being kept. Also, those field houses create a permanence so that nobody can go out there when you're not there and think, oh, well, I can just grow crops here. When they see a house there, they know, oh, this is somebody's property. So it's the equivalent of fences. When you build a field house, you're essentially saying, this is our land. Now, the ball courts didn't come in until about 800, and they were a very important part of Hohokam society. But what we find is that the ball courts are distributed, scattered along the canal systems. So even when they get this big push for a new religion entering the area from Mexico, from Mesoamerica, it's still working within the canal irrigation communities. And one of the things that we now believe about the Classic period, which is the last occupation of the Hohokam, is that they were breaking up the system, and lineages had started taking control. And so it's how they organized themselves started to influence the efficiency of the system, and it may not have been that efficient. So I always like to say, environment is a big deal, but it's the way people organize themselves and the decisions they make that are just as important in anything that happens in the environment. And I wanted to show you Pueblo Salado is an example. This canal was added late in the 1300s. Here's the Pueblo Grande system, and they added this one here. It's an independent village, Pueblo Salado. So keep that in mind, and I'll talk about that later on. And of course, the platform mounds were the spread, interestingly enough, about every 3 miles along the canal system. And so there was, obviously there was some kind of zoning that went on as to where you could build a platform mound relating to how far you were from the next platform mound on the irrigation systems. So you can see that these canals are the backbone of Hohokam society and history for the entire occupation of the Salt River Valley. And then I talked about Las Colinas. You can see how the system ended here, and they had as many as 10 possible platform mounds. And to give you an idea, that canal system too had a population of between 4,000 and 7,000 people that was supported by that one canal system, which is, for prehistoric times, it's pretty sizable.
Now, because of their population size, did they work more on maintaining the canal, that they got that water, was sure to get that water?
Well, how much you worked on it would be based on how much flooding is going on, what the size of your village is, and how much canals are coming off the head gate. So there's a lot of factors. But if you have a larger population, you have more people that can work on the canals too. This is a drawing of the airport. This is what the airport used to look like. And this is based on archaeological data. It's probably pretty accurate. Quite a bit different, huh? Now, one of the things Jerry did is he looked at the different sizes of canals and shapes, and one of the things he found is they start wide and shallow, and they end up narrow and deep. And the reason for that is because it's changing the velocity of the water the further it gets from its origin to maintain that velocity that they're looking for. So it's the size and shape of the canal that helps you control the velocity. And then we look at the canal sediments. Here's a canal that was dug in Mesa. That's Gary Huckleberry. He's a geomorphologist. He's done a lot of work on canals. And you can see, this is what we see when we cut into a canal. It's beautiful. And all that sediment can tell us stuff. For example, whether it's clay, slow moving water, sand, medium moving water, gravel, fast moving water. And what we find is that most canals have a variety of different sediment size and sorting, which tells us that the flow in the canal was varying from season to season and year to year. So they constantly have to be cognizant of the velocity and changes that they have to make in the canal. And the nitrogen and potassium is the important components. Most canals only lasted 50 to 100 years before they had to be completely rebuilt, or they had to, now you say, oh, charcoal, great, we can date that. No good. That probably washed in. Has nothing to do with the canal. So you have to go to what we're doing, luminescence dating now of individual grains of sand. Luminescent dating dates the last time the sun shined on that grain of sand because it quit charging with energy, and you can measure the luminosity of that sand grain, and therefore you can use that to date when the sediment went into that canal. And it's the latest and greatest, and it's working really well. It's also extremely expensive, as you can imagine. Here's, you can see a smaller canal within a bigger canal. It's typical. They start out with big plans, and then they realize, oh, we got to make it smaller because the sediment loads and the velocity of water. And here's the things, the gradient, canal morphology, canal channel roughness, and amount of water released are all the things that affect your velocities. So people actually have come up with mathematical formulas that the Hohokam were apparently using to determine the engineering. Here's a small canal and another small canal, but two entirely different episodes. That's not unusual. It's at Sky Harbor. And we look at freshwater shelves that are in the sediments. They tell us the season that the sediments were deposited, because some shells actually only live during certain seasons, or at least they're in certain cycles of their life. And so, for example, if you get a FISA, like this one, that's standing water only. And then ostracods, so that if you get these tiny little things, and these are really blown up big, they're really tiny, that tells you the salinity of the water in the canal, because each species has a different tolerance for salinity. And then now we're looking at diatoms, single cell algae with siliceous cell walls, and they are sensitive to different environmental factors, and we can use them to also determine the seasons of when the water was going in there. So here's how a headgate system worked. This is at La Ciudad at Luke's hospital, and there's a headgate here, and I'll show you. They had reservoirs. They built reservoirs to preserve water, and then we could look at the pollen, and we can tell when the water was going in there, for example, from the pine pollen. And then we find there's vegetation growth in the reservoirs and the canals, and sure enough, that's important because we find them burn a lot, because you have to, that will impede the flow of water, and so you have to burn the vegetation as part of your maintenance cycles. And here's that lateral gate. It was a series of post holes, and there was 100 stones that were around the gate, and this is what the gate looked like. Bundles of reeds, so that the water is restricted to the center portion here, and then you can put a piece of textile or leather there and stop the flow pretty much, and then remove that when you want water to go. So again, your head gate is going to allow you to regulate the flow of water into that canal, and we've actually now dug a few of these. And then also, you know, the baffles to slow the water down where there's curves. There was erosion here, so they added the cobbles. And what we find also interesting, when they had blowouts, they never wasted water, so they just made the blowouts into reservoirs and used the water until it dried up. And this is the earliest canals, is in Tempe, and you can see here all these canals. They had to sort them all out. Here it is in the system one here. But what's interesting is that for this canal here, which is the earliest one, then there's this canal 3 that has a branch here, and this is a major branch, so you got to slow the water down here. So what did we find when we excavated this? 3,447 sherds, 1,475 cobbles and groundstone, and 628 post holes. So that many posts. This is the work just to get control of the velocity at this turn that was not working efficiently. And here's a photo of it to give you an idea of what they find when they excavate it. Here's a person here to give you an idea of the scale. 2.6 tons of cobbles they had to put there to get control of that turn. And here, where they split it, it was blown out this wall, so they put 75 posts here. And then here's some canals. This is typically how we find them. What happens, it fills up. Rather than dig it out, you start a whole new canal next to it. It was actually easier to construct a new canal than to clean out the old one, because you can control the engineering. You've lost a lot of your engineering when it fills up. And so here's one canal, and these are all channels of the same canal. And here you can see they actually put a post here to shore up a blowout area. And that's underneath, this is underneath the runway at airport here with the cobbles. And then I want to show you this walk-in feature at Pueblo Grande that was excavated, where they actually put a terrace next to the canal, and they found footprints and a broken vessel and footprints. And there's an actual footprint of a Hohokam, and from that. And so finish up quickly. I've just been told stop. And so here's some fields we dug, and I want to show you. There's me in the size. You can see this is a massive canal here, and this is how we sample it. And then here's where they built a weir inside a canal so that it could branch out. And all they need to do was slow it down enough to get over that, and then the water flow is adequate for that. And so to finish with just a minute here, is that we now realize there might have been problems with infectious diseases from the water itself, which could have contributed to the Hohokam collapse, including bacteria, viruses, protozoa, helminths, which is your roundworms, tapeworms. And so we know that those were part of the problem. And if you think the Salt River is not a mighty, look at that. Brand new bridge, 93, is taken out. And then the last thing I'm going to talk about is we have Pueblo Salado. I mentioned that. And we actually excavated this, and there was sediment inside each of the rooms, and they just came back and just put new floors on top of the sediments. And this was a last-ditch effort to build next to the river again, to go back to the old way. And they said, you know what, I don't care. There's farmland there, and we'll put up with the flooding. We'll just have to renovate our houses constantly, and that's my talk about Hohokam Irrigation.